So let's work through some of these problems on the review. So if you look at this first one, the main thing you need to watch out is we're finding area and not just x. A lot of people made the mistake of going, oh, find out what x is and we're done. But we need to find the area of a triangle. An area of a triangle is 1/2 base times height. But the base and the height are the two legs of the triangle. We know the height, but we don't know the base. So in order to find the base, we are going to have to use Pythagorean theorem. So to find the third side, when you have the hypotenuse, we have to take, so we know that x squared plus 7.5 squared is equal to 12.9 squared. So to solve for x, it's the square root of 12.9 squared minus 7.5 squared. If you type that in on the calculator, you get a 10.4957. So x is 10.4957. Don't use the rounded version here because that's not the final answer. We are going to round at the end, but we don't want to round here because if you round here and use that answer somewhere else, you get what's called round-off error. So you want to wait until we're actually getting the area before we round. So let's get that number value. So it's going to be 1/2 base times height, or base times height divided by 2 is the same thing. This base was that 10.4957, and then times the height of 7.5. And if you type that on your calculator, you get 39.38 when you round it to the nearest hundredth. And let's move on to number 2. So that's what you would type in on the fill in the blank version of the test. Number 2, compute the area of this figure. Well, this one's made up of two shapes. We have a right triangle and a rectangle. Well, if that's 17, that makes this 17, which makes this 7, because together they have to add up to 24. So we need to find the base, this width across the rectangle, because that's the base of our triangle. We're going to do base times height, and here we're going to do that base times height divided by 2. So we know the height, we just don't know the base again. So we've got to do Pythagorean theorem to find out how wide this triangle and this rectangle are. So once again, we're going to take, to find this missing side, we're going to call that x. X is going to be the square root of the hypotenuse squared minus the leg squared. And when we do that, we get 10. So just to show you, we would take from a calculator square root of, what did I say, 12.21 squared minus 7 squared. And you get 10.0042, so we're going to use just 10 for the, well, we're going to leave it for that. So to find the rectangle, or the triangle, let's see, we got to do the area of the triangle plus the area of the rectangle. Now, the area of the triangle is going to be that 10 point yada 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 times the height of 7 and divide by 2, or 1/2. And the area of the rectangle, so we got to find this value and then this value, and we're going to add those together. So this one is just 17 times that 10, whatever. Well, to keep it exact, I'm going to just do, let's see, which one first. The base times the height, we said that number, which is actually a lot longer. If you use the calculator version, it doesn't round it for you, times 7 divide by 2. And then the rectangle, I'm going to arrow up so it uses that nice long version of that number again, times 17. And I'm going to take, that's the area of the triangle, that's the area of the rectangle, so I'm going to add those two areas together. I want to take that area plus that area, and you get 205, and that one, I think 205.01. If it doesn't say, we're just going to do the nearest whole number, so 205. So this area for both of them that one plus that one is 205, and it's square meters, but we don't have to put the units because it's a fill-in-the-blank question. Okay, number 3. To find the area of this one, to find the area of a triangle, we've said it's just area is equal to base times height divided by 2, or 1/2 base times height. Well, the base is 25, so it's going to be 25 times the height and divide that by 2, but I don't know the height. So here's where we've got to use a little bit of geometry skills again. Well, if this whole base is 25 and this part's 8, that means this part's 17. And so we have a right triangle with the hypotenuse of 23, a base of 17. So to find the height, we're going to have to do the square root of the hypotenuse squared minus the leg squared again. So 23 squared, so square root of 23 squared minus 17 squared, and you get 15.49 basically is the height. But like I said, I'm not going to use that rounded division. I'm going to use this number, and I want to take my base times my height. My base is 25 times that height right there, and then divide by 2. Base times height divided by 2 is 193.649. It says round to the nearest tenth, so 1 decimal place, 193.6. So 193.6. I didn't write down what that height was. We said it was about 15.492. Okay, so the answer though would be 193.6. Now for number 4, to get the area of an equilateral triangle. Well, step 1, area of a triangle, once again, is base time 1/2 base times height, or base times height divided by 2. I know my base is 8, so that's 8 times something and divide by 2. Well, I need to find this height. So to find that height, if we look at just one of those triangles, this is 8, this is 4, so we're going to have to do the square root of 8 squared minus 4 squared. That's going to give us the height, because we're doing Pythagorean theorem again and solving for the missing leg. So let's do the square root of 8 squared minus 4 squared. And we get that number, and I wanted to take that number times the base, which was 8, and divide by 2. And there's our area is 27 point, it said round to the nearest tenth, so 27.7. So the area is 27 point, I forgot what it said, 27.7. So those are our area problems. Let's move on to how to find the cotangent of theta when all they told us was what sine of theta was. So step 1, draw a right triangle and pick one of the two acute angles and call theta. So I'm going to use this one here. Well, sine is opposite over hypotenuse. So the opposite has to be 3. The hypotenuse is 5. So I need to do Pythagorean theorem and find this third side, because cotangent is adjacent over opposite. So I know it's something over 3. I just got to figure out what that something is. So do Pythagorean theorem. And when we're working backwards to find the leg, we've already talked about that that's going to be the square root of 5 squared minus 3 squared, which is 25 minus 9, which is square root of 16, which is 4. So now I know that adjacent is 4, opposite is 3, so it's 4 over 3. So cotangent of theta is 4 over 3. Okay, for number 6, well, let's move this up a little so I have a little more room here. Let's label what we know. We know side AC, the hypotenuse, is 10, and BC, the side opposite of our angle, is 8. So we can do Pythagorean theorem and take the hypotenuse squared minus the leg squared equals the other leg squared. And that will give you 100 minus 64, which is 36. So we know the hypotenuse for the other leg is 6. So now we know all 3 sides. We can evaluate the 6 trig functions. So sine of theta, and theta is the top angle, not the bottom, so don't let that confuse you from the notes. The picture was on the bottom. But Sine of theta is opposite over hypotenuse. So that's 8 over 10, which are both even, so we can divide by 2 and you get 4/5. So sine of theta is 4/5. That means I actually know cosecant of theta. If I work at the other end, we'll do 2 at once here. Cosecant is the reciprocal of sine, so that would be 5/4. So let's do cosine of theta. Cosine of theta is adjacent over hypotenuse. So adjacent over hypotenuse is 6 over 10, which is 3/5. And the reciprocal of cosine is secant. So secant of theta would be 5/3, the reciprocal. And we need tangent of theta. Tangent is opposite over adjacent. So that's 8 over 6, which reduces to 4 over 3. So tangent of theta is 4/3, so the reciprocal function, cotangent of theta, will be 3/4. And we are through with the front side, so let's move on to the back. Number 7. If little c is 18, so step 1, we label what we know. Angle A is 64. And we want to find little a. Well, you actually have a choice on this one. You could either do the trig function, and the trig function says we're looking for little a, so we're looking for the opposite of the angle, and we know the hypotenuse. So we could say opposite hypotenuse is sine. Sine of 64 equals the opposite, which is a, over the hypotenuse, which is 18. And then you would multiply both sides by 18. That way works. Or some people like the law of sines better. As long as you have one ratio of a side and the angle across from it, we can set up law of sines, and that would be 18. So this is 18 over the sine of 90 equals a over the sine of 64. Multiply those two, divide by that one, and we get our answer. And either way you do that, we type that. As long as you're in degrees on the calculator, you type that in, you get a is 16.2. Either method. You don't have to use both. You get to pick one or the other. For number 8, if little t is 30, so let's label that one. Little t is 30. Little s is 28.7, and we want to find angle r. So that's my theta this time. So we have, from that angle that we're looking for, the adjacent leg, and we know the hypotenuse. Adjacent hypotenuse is cosine. So I would say cosine of theta equals the adjacent leg over the hypotenuse. Now to undo cosine, the only way you can get rid of cosine is to do its inverse operation, which is the inverse cosine. So we have to do that to both sides, which gets rid of it over here. And our means mathematically to find theta, we just take the inverse cosine of 28.7 over 30. That's one way to do that. And we could type that in the calculator to get the answer, or we could use the other method. The other method says, well, let's find, we're looking for theta. We don't know theta and we don't know r, so you really can't use that one. But we can find s. And once we know s, these two angles have to add up to 90. So we could take 30 over sine of 90 equals 28.7, because we knew that side, over the sine of s. And multiply those two, divide by that one, and then we have to inverse sine that. So inverse sine of 28.7 times sine of 90, divide that by 30. That'll give us this angle. Once you know that angle, subtract, or add these two angles together and subtract from 180, and you get the third angle. I would this one, I think cosine is the easier way to do that one. And when you do, you get 16.9. So 16.9 for the answer. Oh yeah. And another thing you could do on this one, if we know the hypotenuse and we know one side, if you didn't want to find the other angle, you could do Pythagorean theorem and then just do, and not have to switch angles, just do that, do Pythagorean theorem of 30 squared minus, what is it, 28.7 squared. I'm getting too much scribble on here. 28.7 squared. and then that would be sine of r. So either method works. There's multiple methods. I think the easiest is just inverse cosine, but you have choices. So if you have questions, ask your teacher. Let's look at, I need to move that back a little. Number 9. And this one you have to draw a picture. An airplane climbs an angle at 15 degrees. So here's 15 degrees with the ground. Find in the nearest foot the distances it has traveled. Well, airplane travels diagonally. It doesn't go horizontally on the ground. When it's has attained an altitude of 1,000. So now we have a picture. We're looking for the hypotenuse. We know the opposite, so you could say sine of 15 equals 1,000 over x. Well, this one's a little trickier to solve. So you'd have to multiply both sides by x to get it out of the denominator, and then turn around and divide by sine of 15. So x would be 1,000 divided by sine of 15. That way works. We could also, if you don't like that method, we could say 1,000 over sine of 15 equals x over sine of 90, and multiply those two and divide by that other one, and we get x that way. Either way you do that one, you get 3,864. 3,864. If you need to see me type that one in, that would, if I do, well, it's just 1,000 times sine of 90 divided by sine of 15. 1,000 times sine of 90, get outside the parentheses, divide by sine of 15. And you get that to the nearest whole number is 3,864. So there, I did at least one on the calculator that you could see. So let's move on to number 10. Number 10 says, find the secant of p. Well, we just have to know what secant is. Secant is the reciprocal of cosine. Well, if you look at it, it's on your formula. Secant is hypotenuse over adjacent. Well, we have all that stuff listed. We have all the sides. We just have to realize we're talking about this angle here. So this is opposite. This is hypotenuse. This is adjacent. So hypotenuse over adjacent is 20 over 16. And then we need to reduce. Looks like 4 goes into both of those. 20 divided by 4 is 5. 16 divided by 4 is 4. So secant of p is 5/4. So, sorry, I hope there wasn't any confusion there. I had to make a little cut because I goofed up on the video and accidentally paused it and didn't know it, so now I'm going to pick up. So let's look at number 11. For number 11, we want to find all the solutions for a triangle with f equals 15, e equals 14, and capital F is 33. So let's label what we know. Little f is 15, little e is 14, and angle F is 33. So we have one side and the angle across from it. When we have that, we can use law of sines. So I'm going to take the side over the sine of the angle. Oops, the angle was 33. Sine of 33, I was looking ahead, equals, what are we trying to find? We're trying to find all solutions. That means we need everything. So we need every side and every angle that's not labeled. So 15 over sine of 33. There's the one we do know. And, well, the only other one I know right now is side 14. So I can do 14 over sine of e. So multiply the two you can. Divide by 15. But that's still sine. So to undo sine, we're going to have to do the inverse of all that. So the inverse sine of 14 times sine of 33 divided by 15. So let me bring up my calculator and, whoops, sorry, I've been doing other stuff since. And so we want to do inverse sine of 14 times sine of 33, not 333. And I want to divide by, what was I dividing by? I already forgot. So let me go look and see. Divide by 15. So divided by 15, And so 30, I think it said round to the nearest tenth, so that'd be 30.6. So 30.6 is, I need to make sure I'm still recording because that's what happened before. Yep. So E is 30.6. 30.6, yes. So 30.6. Now, if we know E, and we know angle E and angle F, we can add those together and subtract from 180 and get angle G. So if we take 30.6 plus 33 and add those together, subtract from 180, so I'm going to take 30.6 plus 33, add that, oh, didn't mean to move the screen on y'all, sorry. Add that together, subtract it from 180, you end up getting, for angle G, is 116.4. 116.4. So now that I know angle G, I can find little g by doing our law of sines again. We already know, so 15 over sine of 33. That's the ratio we do know, so I'm going to use that one. And now I want to do little g, not an e, little g over sine of the angle across from it, which is 116.4. So we're going to multiply those two and divide by that one. So I'm going to take my calculator and do 15 times sine of 116.4. 15 times, oops, my calculator's not on the screen for you to see, is it? Sorry, I guess I can just make it where you can see what I'm typing. And I need to fix, I completely forgot I was using this in another class, so 15 times sine of, let me double check, sine of 116.4, 116.4, get outside of the sign, and we divide that by 50, oh, it's 14 times, no, divide by sine of 33. So divide by sine, I was looking at the wrong one for a second, sine of 33. And I press enter, 15 times sine of 116 divided by sine of 33, 24.7. So, whoops, wrong screen. So G is, I already forgot what I said. Where'd it go? 24.7. So 24.7. So we have angle E. Now we have all three sides and all three angles, and we are done with number 11. Number 12. Given a triangle, AB, A, little a, and well, let's draw the picture because we have nothing to draw on here. So I'm going to draw a triangle. And A, B, C. Doesn't matter how you draw it as long as you label it correctly. Angle A is 13. Angle B is 12. And little a is 12 also. And we want to find C. Well, to find little c, what I would do is look at the one we have. If we have a side and an angle across from it, we can use law of sines. So 12 over sine of 13. Now, I'm looking for this side over here. So it would help if I knew the angle across from it. Well, if we know two angles and we have a triangle, we can find the third angle. So I'm going to take 12 plus 13. 12 plus 13. Well, that's 25. Subtract that from 180. And that gives me, what is 12 plus 13? Subtract. I'm looking at the, trying to find the problem. Oh, 155. So that tells me, we'll put it in a different color. This angle right here is 155. So now I can set up my ratio. Let me erase that, my scribble work. Oh, get the eraser. So 12, side 12 over angle 13 is equal to side C over the angle across, sine of the angle across from it, sine of 155. So I'm going to multiply, sorry, I'm getting carried away. I'm going to multiply those two and then divide by the other one. So C is 12 times sine of 155 divided by sine of 13. So bring up my calculator. 12 times sine of 55 divided by sine, or 155, sorry, sine of 155 divided by sine of 13. So divided by sine of 13. And you get 20, does it say to round to? Round to the nearest tenth, so 22.5. 12 times sine of 155 divided by sine of 13 is 22.5. So, whoops, back on the wrong screen again. So C is 22.5. Now, number 13. I'm going to clear that off so I have a little more room. Let's give myself a little bit of space here. Given a triangle BC and angle A. So let's draw the picture. Look, once again, pick where you want to start. A, B, C. Angle A is 38. Little b is across from angle B is 5. Little c across from angle C is 7. And that's all we know. I have no sides with the angles across from them given, so I can't use law of sines. So when you can't use law of sines, we go to law of cosines. And you find the angle, that's the side we're going to find first. Well, that is, not put a C, that's A. That's the one we're looking for, luckily. So law of cosine says that side squared is equal to the other two, the sum of the other two sides squared, so 7 squared plus 5 squared, minus 2 times each of those sides, 2 times 7 times 5, times the cosine of the angle that was in between there. Now, that's A squared. I'm looking for A. Well, to unsquare something, we take the square root. So, square root of all that, I can type it directly on my calculator. I have everything over here, so I can just type that in directly on the calculator. So, that's going to be square root, and you can do it all in once. If you want, you can split up and do pieces at a time, but 7 squared plus 5 squared minus 2 times 7 times 5. I hope those are right numbers. Let me double check. 7 squared and 5 squared. Yes. Times the cosine of 38. So times cosine 38. 7 squared plus 5 squared. 2 times 7 times 5. Cosine of 38. 4.3 if we go to one decimal place. So 4.3 is our A. And the very last question, I'm going to use this space over here. The very last one says find the area. Well, you were given an area formula that's down here in this bottom right corner, or that says, okay, area of a triangle, when it's not a right triangle, the area is always 1/2 of one side times another side times the sine of the angle in between those, sine of 103. And so that's all we have to do is type that in and say, I forgot my numbers, 15 times 19, 15 times, I forgot my 1/2, so I'll just divide by 2 at the end. 15 times 19 times the sine of the angle that was in between there was 103. And I want to take that and divide by 2 because it was 1/2. And you get 138 point, it says round to the hundredth, so 138.85. The area is 138.85. It would be square centimeters, but you were given the units, so you don't have to worry about writing units at all. They're there for you to already know. And this is what the test is going to look like. So good luck.